Hello and welcome back. I am Sam, your lead tutor. Today, we are going to talk about the biggest revolution in networking since the invention of the router. We are tackling K67, SDN and NFV. These acronyms stand for Software-Defined Networking and Network Function Virtualisation. This isn't just about new gadgets, it is a fundamental shift in how we build networks. We are moving from manually configuring individual boxes to programming the entire network as a single system. This is the technology that powers the cloud, 5G, and modern data centers. Our goal today is to understand how we separate the network's brain from its muscle. Let's use my scaffold and ascend method to break this down. In traditional networking, every router is smart. It has a brain, called the control plane, which decides where traffic goes. And it has muscle, called the data plane, which actually moves the packets. The problem is, if you want to change a policy, you have to log into every single router and update its brain. It's slow and error-prone. SDN changes this. We take the brain out of the routers and put it in a central server called the controller. The routers become simple forwarding devices, just muscle. This is control plane separation. Now, if you want to change the network, you just program the controller once, and it updates thousands of devices instantly. This separation gives us massive flexibility. We can create what we call overlay networks. Think of the physical cables and switches as the underlay, the road. The overlay is a virtual tunnel that runs on top of it. Technologies like VXLAN allow us to stretch a single network across different buildings or even different cities. This means you can move a virtual machine from a data center in London to one in New York without changing its IP address. The physical network doesn't change, the software just reroutes the tunnel. This leads to the concept of infrastructure as code, where you manage your entire network using scripts instead of screwdrivers. While SDN changes how we control the network, NFV changes what the network is made of. NFV stands for Network Function Virtualisation. Traditionally, if you needed a firewall, you bought a specific metal box from a vendor. If you needed a load balancer, you bought another box. The core principle of NFV is disassociation. We take the software that does the firewalling and run it as a virtual machine on a standard, cheap server. We stop buying proprietary hardware. This reduces costs and, more importantly, increases agility. You can download and deploy a virtual firewall in 10 minutes, rather than waiting 6 weeks for a hardware delivery. It is important to understand that SDN and NFV are different, but they work best together. NFV creates the digital components, the virtual firewalls and routers. SDN provides the intelligence to connect them. We call this service chaining. The SDN controller can say, take all traffic from the marketing department, steer it through the NFV firewall, then through the NFV load balancer, and finally to the web server. Together, they create a fully automated, software-defined data center where the entire infrastructure can be deployed and managed by code. Let's look at a real-world scenario. A retail client wants to open 50 new pop-up stores in a single week. Using traditional networking, this is impossible. You would have to configure 50 routers manually and ship them. But with SDN and NFV, we use SD-WAN. We ship generic, empty hardware devices to the stores. A non-technical person plugs them in. The device calls home to the SDN controller. The controller identifies the device and instantly pushes down the configuration, the security policies, and the virtual firewall software, NFV. The stores are online and secure in minutes. That is the power of K67. As an engineer, you must also know the risks. Centralizing the brain creates a single point of failure. If the SDN controller goes down, you might lose the ability to make changes to your entire network. It also creates a massive security target. If a hacker compromises the controller, they own the whole network. Finally, it adds complexity. Troubleshooting an SDN network requires new skills, understanding APIs, Python scripting, and Linux, not just typing commands into a router console. For your portfolio, K67 evidence shows you are ready for the future. Use the STAR method. Situation: we needed to update the firewall rules across 20 different branch offices to block a new security threat. Task: I needed to ensure consistency and speed, avoiding manual errors. Action: I used our SD-WAN controller, an SDN tool. Instead of logging into 20 devices, I defined the security policy once in the central dashboard. I then pushed this policy to all the edge devices simultaneously. Result: the deployment took 5 minutes instead of 5 days, with 0 configuration errors. Reflection: I learned that centralized control eliminates configuration drift and ensures security compliance. If you are doing your major project, you are likely using K67 even if you don't realize it. If you are building a network in AWS or Azure, you are using SDN. A VPC, Virtual Private Cloud, is an overlay network. In your report, explicitly state this. Right, I utilized SDN principles by configuring the network topology via the central cloud console rather than configuring individual switches. If you deployed a virtual appliance, right, I leveraged NFV by deploying a software-based load balancer to reduce costs. This shows you understand the theoretical principles behind the cloud interface. To conclude, SDN and NFV are not just buzzwords, they are the new normal. Remember the core concepts. SDN separates the brain from the muscle to allow central control. NFV turns hardware boxes into flexible software. Your role is evolving. You are becoming less of a cable plugger and more of a network programmer. I challenge you to look up Ansible or Python for networking after this session. That is the language of the modern network engineer. Thank you for your focus, and I will see you in the next session. Thank you so much for joining me today. I hope you now feel more confident in mastering this topic. If you found value in this session, I have a small favor to ask. Please hit that subscribe button, give this video a like, and follow our channel. It really means a lot to me and helps the algorithm show these lessons to other apprentices just like you who need support. Don't forget, you can download today's slides and the full transcript at www.mentorinai.com EPA Hub. While you are there, check out our mock interview and portfolio review services to make sure you are fully ready for your EPA. See you in the next video. Keep learning.